Hello again, Morgan here. We are on page 6 of the gases outline today, and we are talking about the ideal gas law. We showed on the previous page that PV is equal to nRT, and we're going to be using that to solve some problems today. Now, typically what I would do in a classroom situation is probably solve one of these problems and then send you off into groups and let you argue your way through to see how you can do. So that's kind of what I'm going to encourage you to do today. Let me do number 1. Then I'd like you to pause the video, go out, do the problems, come back and see how you did. So we're starting off with 25.00 grams of neon. It's at 2.99 atmospheres and 400 Kelvin, and we are going to be looking for the volume of the sample. Now, I am a very big fan of underlining and identifying what we know, what we don't know, okay, what we're looking for, okay. So I really want you to get in the habit of doing all of that. So, grams is not good for us. Let's get rid of that. 25.00 grams neon times 1 mole of neon, and 20.18 grams of neon is its molar mass. Grams of neon is going to cancel. I like to kind of over-exaggerate when I'm canceling. Okay, and I get 1.239 moles of neon, and we work with moles here. Okay, now PV equals nRT. I'm looking for V, which equals nRT over P. Give myself plenty of room to work here. I have my moles, it's 1.239. Now, R. I'm going to look at the question here. This is in atmospheres, so that tells me that the R I want to use is 0.0821 liter atmosphere per mole K. Now, I know that in some lists this comes out as 0.08206, and that's fine if you want one more sig fig, okay? 4 is almost always enough for what we're doing. 400 Kelvin with the decimal, which is good. That's a 3 sig fig temperature, okay? And the pressure downstairs, 2.99 atm. Okay, I like to set up my fractions like this with only one line. I'll move stuff upstairs and downstairs as necessary. It's just going to make it easier to cancel things, less confusing. Atmospheres is gone. Moles is gone. Kelvin's gone. Okay? And when rounded off, 13.6 liters. Okay? So that's what this would look like. All right? Now, I'm pretty serious here. Pause the video, go, work all the problems on this page and on the next page, and then come back and check to see how you did. Okay, welcome back. Let's see how your work turned out. So you have an ideal gas at STP. That gives you how many moles. We're looking for moles. Okay, so PV equals nRT, N equals PV over RT. Our pressure is 1.00 atmospheres. That is standard pressure. Of course, I could have put it in other units, but I like atmospheres. 35.4 liters. R, because this is atmospheres, it's going to be 0.08. Watch this carefully. Don't let your eyes move away from the screen. liter atmosphere per mole Kelvin. The mole in the Kelvin moves upstairs because it's in the bottom of a fraction, and that fraction is downstairs to begin with. Standard temperature is 273 Kelvin. Now, I see atmospheres, liters, and Kelvin canceling out. On my calculator, 1.58 moles if you're paying attention to sig figs. Okay. Number 3. I've got 64.00 grams of oxygen gas. Remember that's O2, it's diatomic. 273 Kelvin, 1.00 liters. And I'm looking for the pressure. So 64.00 grams O2. Write out everything every time, because if you make a mistake, I can, or the grader who's reading your AP exam, can try and give you partial credit if you have shown what your thinking was. And if we find evidence that you actually knew what you were doing and you only made a little silly boo-boo like a molar mass or something along those lines. Okay? So 4 sig figs for the moles. 4 there, that's going to give us 4. PV equals nRT. I'm writing it every time. P equals nRT over V. Give myself plenty of space. 2.000 moles. R. Now, well, I'm looking for pressure, so I can choose to use atmospheres. 0.0821 liter atmosphere per mole K, 273 Kelvin, and 1.00 liters. All right. Look for some stuff to cancel. Liters, moles, and Kelvin, which is going to leave me in atmospheres, which is one fine unit for pressure. Okay? Rounded off to the 3 sig figs, 44.8 atmospheres. Okay? And it was identified as O2 gas. Now, I want to make kind of a big deal, not a really big, but at least kind of a big deal here, that I'm not trying to turn this test into a referendum on significant figures. Okay? I'm ending up with almost 3 for all my answers because that's what most of the instruments that we work with would end up giving, especially thermometers, okay? So let's not read too much into that, okay? We learned sig figs last year. You know those rules, okay? Now we're just trying to really make sure that we understand the chemistry and not necessarily just significant figure stuff. The AP exam is not much of a referendum on sig figs either, don't worry. So what is the temperature? We're looking for temperature. I got 1.00 moles of neon. I've got 3.75 liters. I've got 1.25 atmospheres. So if PV equals nRT, T equals PV over nR. The pressure in this case is 1.25 atmospheres. That's about the equivalent of swimming to the bottom of your typical swimming pool, okay? Volume, 3.75 liters. R in atmospheres, 0.0821 liter atmosphere. Mole K is upstairs. All right. And moles is 1.00 moles. I'm going to see moles cancel right away. I'm going to see atmospheres cancel and liters. So I'm left in Kelvin. That's great. That's temperature unit. And this is a chilly 57.1 Kelvin. Okay. All right. So that's page 6. Tune back into the next one for page number 7. This is Morgan, signing off.